Floods are among the most devastating natural disasters on Earth. But how do we see and map floods, especially when heavy rain and clouds block our view from space? That's where SAR, or synthetic aperture radar, comes in. Unlike optical satellites that depend on sunlight, SAR uses microwave radar signals that can penetrate clouds, rain, and darkness, making it the ultimate tool for flood detection and monitoring. In this video, we'll break down exactly how SAR works in flood mapping, step by step. SAR, synthetic aperture radar, is an active remote sensing technology. It sends out radar pulses from a satellite or aircraft, then measures the energy that bounces back from the Earth's surface. Each surface, water, vegetation, soil, or urban area, reflects radar differently. By analyzing this backscatter signal, SAR can create images that reveal where flooding has occurred, even when the ground is hidden beneath storm clouds. Why SAR is ideal for flood mapping? SAR has three main advantages during floods. 1. All-weather capability, radar signals pass through clouds and rain. 2. Day and night imaging, it works without sunlight. 3. Surface sensitivity, it detects differences in roughness and moisture. When water covers the ground, the radar signal bounces away instead of returning to the sensor. This causes flooded areas to appear dark in SAR images, while dry land or vegetation looks bright due to stronger backscatter. That contrast is the key to identifying floods. How SAR detects flooded areas? Let's break it down. 1. Acquire pre-flood and post-flood SAR images, for example, using Sentinel-1 data from the Copernicus mission. 2. Pre-process the data, apply radiometric calibration, speckle filtering, and terrain correction. 3. Compare the two images, by calculating differences in backscatter intensity. 4. Classify flooded pixels, areas where backscatter values drop significantly are marked as flooded. 5. Overlay with land cover maps or DEMs, to assess which land types or elevations are affected. This process can be automated in Google Earth Engine, Snap, or QGIS with SAR plugins. Visual patterns in SAR flood maps. In SAR imagery, calm water surfaces reflect radar away, appear black or very dark. Rough water or waves scatter radar, appear slightly brighter. Vegetated or urban areas reflect radar strongly, appear bright gray to white. By comparing multiple SAR images over time, analysts can track the evolution of floods, measure inundation extent, and even estimate recession rates after rainfall. Interpreting SAR polarization for flood mapping. SAR systems like Sentinel-1 provide dual polarization data, VV and VH. Each polarization captures radar signals in different orientations. VV polarization, vertical transmit, vertical receive, is sensitive to smooth surfaces, good for detecting open water. VH polarization, vertical transmit, horizontal receive, helps detect flooded vegetation, where radar penetrates the canopy and reflects off water underneath. Combining both enhances flood detection accuracy, especially in forested floodplains or agricultural zones. Beyond visual interpretation, modern SAR analysis uses threshold-based classification, change detection algorithms, machine learning models, time series analysis for monitoring flood duration and frequency. Some studies combine SAR with optical or LiDAR data to improve flood mapping precision and elevation analysis. Imagine a major flood in the Nile Basin or the Brahmaputra River. Sentinel-1 satellites pass every 6 to 12 days, capturing before and after radar images. Analysts use Google Earth Engine to detect areas where radar backscatter dropped, indicating inundation. Within hours, a flood map is produced, showing where communities, roads, and farmlands are underwater, even while heavy clouds persist. So, how does SAR work in flood mapping? It sends microwave pulses to the ground. Detects differences in backscatter between dry and flooded areas. Works in all weather, day and night. Uses dual polarization for open water and flooded vegetation. Provides rapid, reliable data for disaster response. SAR turns invisible radar reflections into actionable flood maps, helping save lives and resources. SAR is more than just radar, it's a lifesaver from space. By seeing through storms, it gives us real-time insight when we need it most. If you found this video helpful, hit like, subscribe, and share it with your GIS or remote sensing community. Comment below, do you want a full tutorial on flood mapping with Sentinel-1 in Google Earth Engine? Stay tuned for our next video.